Hello, everyone. Good morning and afternoon to everybody. I hope that everybody's doing well this fine Tuesday. My name is Alan Pendon, and I am the Digital Demand Generation Manager here at Electro. And I am excited to present this webinar with VIAVI Solutions on test and validation of multi-fiber cables in a data center environment. This session will be recorded, and links to the webinar, as well as the presentation, will be sent to everyone after the event. All right, today's speaker is Jeremy Davis. Jeremy is a fiber optics solutions engineer for VIAVI Solutions and has spent over 15 years of fiber communications experience under his belt. He is a highly experienced person in the data centers and field testing using fiber optic equipment. Jeremy has focused on applying OTDR technology in the last 5 years with hands-on experience using brilliant OTDRs. At VIAVI, Jeremy plays an integral role in developing test solutions for data center cabling and testing, creating MOPs and customer acceptance. Now, just a little bit about Electro. Electro is the largest testing and technologist services provider. We have over $1.2 billion in inventory, and that equates to having more selections for your testing needs. Electro has invested more than $100 million in new equipment. We have over 122,000 solutions in stock, 27 offices and inventory centers that can deliver to over 100 countries and over 600 specialists to help you. Now, before we start, if you have any questions, please put them in the questions and chats panel, and I will address them with Jeremy. Now, with that, let's get started with the webinar.
And then you can see my my presentation slides.
I sure can.
Perfect. So yeah, well, thanks, Alan, and thanks to Electro for inviting VIAVI to come present today. Again, my name's Jeremy. I'm a solutions engineer here at VIAVI, specializing in a lot of our field portable fiber optic test equipment. And just kind of makes sense to talk about our data center testing equipment today. It's something that has been becoming a more prevalent in the time that I'm spending in the field. A lot of the requirements for the data centers, the testing requirements have taken a big step up. There's a lot of demand to make sure that these data centers, when they go up, that they're functioning correctly. So it's kind of one of these emerging markets where traditionally, we might be talking more telecom, the service providers. Now we have this new kind of, I guess, emerging market where the data centers are really taking a lead in the type of testing that they're requiring. Certainly on installation, and then well as the maintenance side as well. So like Alan mentioned, I'm going to go through my slide. I'll be looking at the chat as we go through. So if you do have any questions that we that come up as I go through the slides, please type them in the chat. We'll try to address them as I go through. Or if not, we'll try to dedicate a few minutes at the end of the presentation to handle any of your questions. But like I said, feel free to ask away, especially if you're new to these types of testing requirements. Pretty simplistic agenda here. Again, this is meant to basically just be a general introduction to what's going on inside the data center. What are they testing? What do those tests look like? And then from there, we'll switch over to the probably usually the most important thing when we're talking about test equipment, being what are the challenges that they're running into, both with the installations, as well as the testing requirements as well. There's some very unique challenges that arise when talking about testing data centers, and especially what we're going to focus on today when you're inside the data center. So we'll go over the types of challenges that we've been seeing out in the field, and then of course get over to the product overview and really tell you what products we recommend and how we go about handling some of the challenges and these test requirements to try to make your testing go that much easier, that much more smooth, right? The whole idea of any kind of testing requirements are, making sure that, while you're on site, you're successful, you get everything done, you get your reports all done, everything's good to go, so that when you pass them back over to the Microsofts and the Amazons and the Metas of the world, they accept those results and don't say, no, you need to go back and do a lot of rework, which again, obviously is going to cost significant amounts of money and kind of take away the majority of your profit for doing those types of testing. So we'll talk a little bit about, what is it, what are the challenges, and then what are the products, and then that should do it here. So kind of if I take a step back, right, when you look at data center testing, you could kind of divide it up into 4 general areas, right, that we're talking about, that we go in detail on the slide. And each one of those areas are just going to have a different set of testing requirements, right? And kind of here on the left-hand side, what I highlighted in green, what we're focused on today is going to be inside the data center. And specifically the construction and activation side of it, typically done by a contractor that'll go in, that have a very specific set of testing requirements that they need to test, and then provide specific reports to whoever they're doing the work for. So again, we'll go in a lot of detail about this, but again, the general idea is going to be lots of connectors, lots of fibers, lots of testing, but very basic tests that you're running. Just to touch real quickly on the other segments. From the inside, you kind of go just outside the data center to what we call campus data center testing, right? So that would be different data centers or different buildings at the same location. Maybe you have 3 or 4 data centers at a location in Phoenix or San Antonio or some of the other areas that have a lot of construction going on right now. But not very long fiber, still less than, maybe a mile or 2. And again, just really, those types of testing is really just meant to connect the different data centers in the same location. That would be your campus DC. Next step up, the metro DCI would be like, that's now going to connect your data centers within the same city, right? So if I'm in Dallas, right, and Meta has 4 or 5 locations, right, they're obviously going to want to connect those together. And then finally, the long haul data center. So now we're talking about connecting Dallas to Houston to Phoenix, wherever it is. And really, the general idea is the testing requirements will change for each one of those segments. Just kind of similar to telecom, right? If you're inside a central office, you would have some things that you want to do, which will be different than when you're connecting central offices from city to city. So again, this slide does a good job kind of breaking up and kind of explaining what the test requirements are, what types of products you're going to be looking at, those kind of things. But again, today we're really going to be focusing here on inside the data center, right? That seems to be the biggest requirement that we're seeing, and more importantly, the most amount of testing that we're seeing. And really, that's just because it's pretty straightforward, right? Inside the data center, there's just rows and rows and rows of servers that need to be connected via, sometimes shorter cables, sometimes cables that are maybe like a couple hundred feet or so. But again, just massive amounts of fibers, massive amounts of connectors that need to be tested. But again, like I said, very basic tests, right? Again, what we're focusing on today will be like any kind of fiber optic testing, right? There'll be an inspection component to it, right? And that's kind of an interesting one, because a lot of times in the past, we've seen inspection tests recommended, right? And you're using your inspection probe while you're on site, but you don't really need to provide those results. Or maybe if you have a failing connector, you need to take a report. But what we're seeing kind of emerge in this inside the data center testing is that the end face inspection tests are now going to be required, right? And you need to, for every single one of those connectors and every single one of those ports, you're going to need to run a test, save that test, and then provide that to to whoever it is you're doing the work the work for. So we'll talk a little bit more about that, how to go about and trying to make that as easy as possible. The other major component of inside the data center testing will be just a simple loss test, right? And for inside the inside the data center, it's kind of that next step up from just a general light source power meter. What's called a tier 1 test. It basically adds the length and the polarity of the fibers, which we'll talk about in a little bit, but still pretty straightforward. A piece of test equipment that's a light source, piece of test equipment that's a power meter. You send the signal from one end to the other and just confirm that the fiber is good. So basic tests, right? Inspection, tier 1 testing, light source power meter, but we'll talk about some of the challenge that arise to that, mostly just due to the massive amount of tests that you need to run. And then kind of just touch on the campus side, because a lot of times the same contractor that's doing the inside the data center testing will also be tasked with maybe testing the campus fibers as well, right? I mean, they're not probably doing the metro DCI or the long haul, but I've seen some contractors being tasked, during the same job, at the same time having to do the links that connect the campus buildings as well. And usually in that case, it'll be something similar to what you're doing inside, but just adding some kind of OTDR, whether it's unidirectional or bidirectional, just confirming that, again, anytime the fiber is exposed outside of a building, you certainly want to hit that with an OTDR just to make sure nothing has damaged that fiber, right? But again, for today, for the rest of the presentation, we're going to be focusing inside the data center. So again, like this picture doesn't do any justice of what you're actually looking at inside these buildings, right? It's just rooms and rooms and rows of connectors, piece of equipment, many things that, many problem areas that can go wrong. So to go a little bit more in detail, I've kind of divided up the challenges into 3 major areas, right, that I've already kind of talked about, but we'll go into more detail here. The first one is just not only the fact that there are so many fibers to test, but you'll also see many different types of connector styles, right? And not only from job to job, but really in the same job. You could be looking at LCs for your campus interconnects. You could be looking at maybe some of the new duplex fiber connectors like SN that we'll talk about here in a second. But most prevalent will certainly be the multi-fiber styles. If you've heard of MPO, MPO is kind of the one that's most relevant today. And then we'll talk a little bit about the MMC, where some of the connectors are going in the future, right? And it's all just about density. How many fibers can we get in the smallest amount of area? But just presents a challenge, right? Anytime you're dealing with that kind of that massive amount of tests, as well as different types of connectors, right? It's just an additional headache from the traditional testing where you might be doing, 2 fibers, same connector style on every fiber, and just a lot less things to deal with. Next challenge, right? And this is specific to, a lot of the the providers like the Microsofts, the Amazons, they not only want reports and the results sent to them, but they have very specific file naming conventions for each one of those fibers, right? So you could just kind of think about it as that's going to be room, and then the row, and then the server rack, and then the rack location, the port location. These file names can get 20, 25 characters sometimes, and if they're not done correctly, right, they're not going to be accepted, and they'll be sent back. So kind of one of the biggest recommendations that we have here at VIAVI, and what we really try to implement in our test products, are just a way that we could be sure that these file name conventions are done correctly, right? And we'll kind of talk about how we could preload them on the instrument and just make it so that when you do the testing, you provide those results, you're good to go. Right? And you don't need to be called back or even post process. Nobody wants to have to test all day and then go back to the hotel or whatever they're staying and have to rename files or do any kind of processing like that. So our whole goal at VIAVI is to kind of remove all that post processing, ensure that you do everything correctly whether it's the pass-fail thresholds, whether it's the file names or anything else. Make sure that it's done correctly the first time, and I'll talk a little bit more about how we go about that. And it all revolves around preloading these file names correctly so that the technician, when they're on site, really can't screw them up. That they're already loaded in there. All they need to do is run the test and save it. So lots of connectors with, lots of fibers with specific file name conventions that you need to save them. And then the third aspect, and this is what I've seen while working with a lot of the contractors that are on site, are, when you're doing your light source and your power meter measurement, the nature of the test, especially inside the data center, that fiber is very short, only a couple hundred feet, really, and then a connector on each side. They're very, very low loss measurements. So when you perform your reference, if you don't have a good reference, right, whether it's your equipment that could be bad, we'll talk about these test reference cords when we get to that point where, they're just high quality cords that have low loss connections. You really need to make sure that reference is good, because if the total loss of your fiber is 0.3 dB, right, and your reference is off 0.25 or something, you're basically going to be highly inaccurate. Can run into issues where you're actually getting a gain in power rather than a loss, things that are physically impossible. So especially, very relevant for the testers, the technicians that are on site, making sure, I've heard horror stories of them spending hours or days trying to get these references to be good in the past so that they're able to test. And, the Microsofts, the Amazons, the Metas, they require you to actually send in a test of just the reference cords, right? They want to see how good that reference was when it was taken, and if it doesn't pass their expectations or the requirements, they won't accept any of the tests. So all the tests could be done good, named correctly, they're all passing. If you had a bad reference, they'll just kick those results back and make you retest. So very important to have a good reference. So yeah, let's go a little bit more into detail on each one of those challenges, right? Again, in the past, we were mostly dealing with single fibers. You still might run into single fibers inside the data center, but more likely doing when you're going campus to campus or the metro data center interconnects, because the whole drive is for as many fibers as possible and as small of a footprint as possible. At minimum, you're probably going to be working with some of the duplex fibers, but most commonly it'll be some form of the multi fibers, right? And so, what do the duplex fibers look like? Right, I don't know if you've seen any of these connectors so far, but what this slide kind of says is, usually when you're working with a regular LC connector, right, it would be in a duplex form, right? So you have the one cable, two separate physical ports that'll support two fibers with your LC footprint, right? And then the whole push has been trying to, how do we get more fibers in a smaller area, small footprint. So kind of the next variation, right, in the process was what was called a CS connector, right? And the general idea of that was you were able to get 2 times, or basically 4 fibers within the same footprint that you could get your traditional LC duplex. But kind of like 40 gigabits per second or some other technologies that sounded good at first, but the next generation was released so quickly after them that they're kind of getting stepped over. So you might see CS connectors out there, but there's already what's called a SN connector, which again is 1 times better than the previous, and now you're actually getting 3 times, or basically 6 fibers in the same footprint that you would get a duplex LC. So you're starting to see these SN connectors as well, right? And the general point that I'm going to make when looking at all these different connectors is you're very likely you're not going to be using different sets of test equipment, right? what you're going to be needing are specific sets of cables, whether they're reference cables, whether they're adapters on the test equipment, whether they're inspection tips for your inspection probe that we'll talk about, right? Again, it's not going to be a separate piece of test equipment for each one of these, but you are going to need specific sets of cables, of adapters, of tips, whatever it may be. So it's just important to understand what connectors you're going to be working with, on these particular projects, and then making sure that you come in armed with the right accessories, the right tools, even the right cleaning tools, right? All these special new connectors require specific push click tools or whatever it is. So kind of from the test equipment to your cables to even your cleaning tools. So you're going to need to be very be very aware of what you're going to run into, with those with that particular job, just to make sure that you have everything. And then the worst case would obviously, be going on site and then not having the correct, the correct cables or whatever it may be. So again, you'll start to see those, what we call the duplex, high density duplex cables. But for the most part, if you're a contractor testing for any of these data center hyperscalers, more than likely you're at least going to be running into an MPO style connector, right? And if you haven't run into MPO before, it's basically taking one cable or one connector end and placing multiple fiber cores or multiple fibers within that same cable. Most common that you run into is what you see here. It would be one row of 12 fibers. So you see MPO 12. That's probably the most common. If you ever, if you're like me and we're confused by the seeing both the terms MPO and MTP, just the quick clarification on that is basically MPO is the parent, or like the umbrella of all these multi-fiber connectors, right? And MTP is a version of MPO that has very tight tolerances in the manufacturing process, right? You can imagine if you have 12 fibers that need to line up perfectly, you really want to have very tight manufacturing, just to make sure that all 12 of those line up, very perfectly, or as close to perfect as possible. So the way it works out is all MTP connectors will be MPO because they're under the multi-fiber umbrella, but all MPO connectors don't necessarily mean they're MTP. So MTP is a style of MPO that it just has a tighter tolerance of specification. You may also run into MPO 8. MPO 8 would basically, they remove the 4 fibers in the middle and just have 4 on one side and 4 on the outside. So again, just something to be aware of when you're running your testing, right? The test tool needs to be aware that, hey, I'm not going to see anything on fibers 5 through 8 for these cables. So they'll need to adjust accordingly. And then here on the bottom, you also may run into what's called MPO 24, which would just be 2 rows of those of the 12 fiber rows. So again, for right now, this is definitely the most relevant connector style that you'll see in these data centers. But again, everything's about more. We need more density, more fibers, blah blah blah. So you'll start to see the terms MMC 16 and also MMC 24. And again, that's just ways to put even more fibers within the same footprint of let's say of an MPO 12 or something like that. So the MMC 16 is basically going to be one row of 16 fibers across, right? So obviously real important when you're looking at something like fiber inspection, right? You're going to need a fiber inspection tool that's able to go outside the range of the 12 fibers so that you can inspect all 16 of that fiber. And then there's also the MMC 24 is kind of like the MPO 24. Well, now you'll have 2 rows of 12 fibers, right? And then you could just kind of see the difference where you look at a traditional 1 rack unit of fibers, right? If they were SC or even LC, each one of these ports would have, 1 connector or 2 connector. Now you have 24 to where you're getting thousands of fibers really in 1 rack unit. And so you could just think, if you have one of these and you have dozens, if not hundreds of racks within that same data center, that's the amount of fibers I'm talking about, right? It's not a couple dozen, it's not even a couple hundred, it's thousands and thousands of fibers, thousands of tests that need to be managed and named correctly, and that whole thing. So you could just see that the types of challenges that arise from these new styles of connectors. And like I said, I'll get to how the test equipment will adapt to these. You know, again, it's not specific test equipment for all these different types of connectors. It's different types of cables, different types of tips, different types of processes to make sure that we could test all of them, right, and not have to carry around 9 pieces of equipment for each different style. Second challenge, right, a little bit more into the file naming, right? And I have some examples of file name in this list right here, where you could see, you know, again, these names that they're specific down to the port, right? So it's port, rack, row, room, you know, whatever, you know, however they're going to name these. So they just get complicated, and you know, especially if you have a piece of test equipment that requires you to manually type in these values. Not only is the technician going to be there forever typing these in, but very, very likely they're going to fat finger, you know, 1 or 2, if not more, and just, you know, maybe just the results unaccepted just because they think it was that, you know, that particular fiber wasn't tested at all, right? So this is really important. All the piece of test equipment that we're going to talk about in a second, we are able to take these, you know, take lists of these, basically done in an Excel sheet, right? So you just do, you know, if anybody that knows Excel, you could create these file names very quickly, right? And then those file names would be preloaded on the instrument so that the technician will just have to, you know, choose, okay, I'm doing fiber 3, select fiber 3, run the test. If it fails, don't save it, you know, troubleshoot it, you know, fix whatever the issue is, get that thing passing. As soon as it's passing, just hit the save button. They don't need to input these file names or anything like that. So just takes one of the big challenges or issues out of the process, and that these are all going to be preloaded, ready to go. And I make the note even for inspection as well, right? When we talk about our inspection tool, the INX 760, you're even able to preload these file names on the inspection tool as well. Just almost a necessity, if not a definite necessity, to make sure that you're you know, not spending 6 weeks trying to get these file names done, or again, just getting them wrong and just having to go through and parse through thousands of fibers looking for what, you know, what did they mislabel or what did they misname. Right, and then thirdly, the referencing process, right? Kind of like what I mentioned before. You know, it's a very basic test, right? You're going to have a piece of test equipment that's a light source on one end, piece of test equipment that's a power meter on the other. But then again, like I said, you could, when you're dealing with very low loss cables, you know, you could have, you know, let's say like even just plugging in a fiber in and out, you could have the difference of maybe 0.1 dB or 0.2 dB, you know, whatever it may be. So if you don't have a good reference to start with, it's very likely that the test won't even make sense. You know, again, sometimes you could look at, it'll show like it's gaining in power. Sometimes it'll just be like a super low value, like 0.01, you know, and anybody that looks at that test will like, no, I'm knowing that I'm getting more than 0.01, right? I have 2 connectors on each end of the fiber. I'm getting more loss than that, you know, something's up. So the 2 most important aspects about this, right? You'll see what we call the TRC, or the test reference cord, right? Test reference cords are kind of like MTP in that they're very, very high quality, low loss connectors, so that you're starting with just a low loss fiber, right? And therefore, you know, you're likely to get that good reference and then get more accurate values once you start testing your the actual fiber. So again, it's one of these things where they're obviously going to be more expensive than just a traditional MPO cable, MPO jumper. But when I say that there's been contractors out there spending all day, you know, if not multiple days, trying to get references, or every time they need to re-reference, it's another hour of struggling, you know, that's where you make up your money, right? With a good reference cord, you know, a reference takes 2 minutes, right? With bad reference cords, it could take a day, right? So it's kind of what it's worth investing in these high quality cables so that the testing and the referencing goes much smoother. The other important thing, you'll kind of see this MTP Pro tool up here in the top. If you're not familiar with how MPO cables work, there are a couple guide pins on each connector, right? That's basically what these big white circles are on each side of the MMC as well as the MPO, right? And the cable could either be unpinned, which means it's a female side, and it's meant to receive the pin from the other cable, or the pinned cable, which obviously would have a set of pins that you would plug in. And it's important to note that our test equipment, we obviously want to ensure that we have the best possible connection to our test equipment. So all of our test equipment will have pinned connectors, and therefore you need to plug in an unpinned connector into the test equipment. So what'll happen is the first part of the reference requires an unpinned to unpinned cable, but then when you get your testing, you could see that you actually need an unpinned to pinned cable to plug into the fibers that are inside the data center. So what this tool does is it allows you to add or remove pins to these cables, right? So you don't need to have a bunch of different cables with different, one's unpinned, one pinned, blah, blah, blah. In this case, this MTP Pro tool allows you to take cables and either place the pins in or remove the pins, just to make this procedure go that much more smoothly. So again, just the strongest recommendation is that to use these TRC cables, and then again, you'll be saving yourself massive amounts of time having successful references. And again, this is important that the hyperscalers are requiring, they're very stringent with these references. And right, you need to have a reference every 250 tests. Sometimes you'll need to re-reference there, or if there's been more than an hour between tests, they ask for a re-reference. So you actually end up running a lot of references. And again, they're going to look at those, and if they don't see a reference test or reference verification, or again, it doesn't meet their requirements for within an hour of testing or anything like that, they're going to kick back those results. All right, so those are the challenges, right? Pretty straightforward. Lots of connectors, lots of specific file names, lots of referencing that needs to go successfully. So let's switch over and talk a little bit more about the testing side, right, and what they're requiring, right? Number one most important thing with not only with data center testing, any kind of fiber optic testing, right, is connector integrity. Right, and making sure that your connectors are clean, and not just the connectors that you're testing, right? The MPO or the MMC connectors that are inside the data center, you certainly want to make sure that you're inspecting and cleaning, but also the test equipment as well, right? The light sources that we talk about, as well as any kind of OTDR port, they're all going to have fiber optic connectors inside of it. Right, and if you're starting with a dirty connector on a light source, very likely you're not going to be able to pass a reference, even if you are using the high quality TRC reference cords. So, any presentation that you've probably attended from VIAVI, you've hopefully seen this slide, and it's basically our recommended workflow or job flow for working with connectors and an inspection tool. The biggest pushback that we get when somebody says we don't want to, why do I need to invest in an inspection probe? I clean my connectors, before I plug them in, right? And the main pushback on that, there's two major pushbacks. The first is if that connector is clean, the only thing that you could do to it by interjecting a cleaning tool or exposing it to whatever tool you're using, the only thing you do is make it dirty, right? Or introduce dirt, or worst case, even scratch it. So the whole point of starting with an inspection first is, one, if it's clean, don't mess with it, right? Don't waste your push clicks. Again, these MPO push clicks are expensive, right? They're not like your traditional SC push click tool that you could find on Amazon for 10, 15 bucks. These things are a couple of $100 and only have a certain amount of push clicks in them. So like I said, you don't want to be wasting them if you don't have to. But the bigger issue and the bigger concern is if you introduce permanent damage or a permanent defect, right? So if there's some kind of particle on your cleaning tool that scratches that connector, now you need to replace that, right? And it may not be that easy. You might have to replace a whole cable, right? And because these cables have massive amounts of fiber, again, the cost of that cable is going to be much higher than your traditional simplex fibers. So what we recommend, right? Inspect. If it passes, don't mess with it. If it fails, clean it, and then always reinspect, right? Make sure that exactly what's going on. Did your cleaning tool fix it, right? Multi-fibers mean you have a much more of a possibility of failing, right? One connector compared to 12 connectors to 16 connectors. And what you'll see is a lot of times you might run an inspection test and you fail fibers 3 and 6 while the rest pass. You introduce your push click tool and now 3 and 6 pass, but 6 and 9 fail or something like that. So real important to verify that even after you use your cleaning tool that you reinspect. And kind of what I said before is this was normally just recommended just to ensure that your other testing went well, but now with these advanced tools and just the massive amounts of fiber connections inside these data centers, that the hyperscalers are making this a requirement that you now need to test, save, and provide a report of these connectors, right? And then some of the things that we've seen out there, right? Again, the cracked is probably the most important use case for testing, because if you have a cracked connector, you could clean that thing all day. You're never going to make that thing pass, right? The only way to understand that you have a cracked, a permanent defect is to use that scope. And then that's also information that the hyperscalers are going to want to see. Like before they go and rip out a cable or invest in replacing something, they're going to want proof, right? And this kind of says, yep, that's not, we're not able to fix that connector. We need to replace it somehow. And then some of the other random defects that we've seen, on the MPO cables. But again, it's just important. With a simplex fiber, you have one core that you need to be concerned with. Duplex, you have 2. Now you have 12, 16, 24. Just the potential of failing a connector just goes up that much more, right? So if you talk about an inspection tool in a kind of from a general view, right? What are the the requirements that you're going to want, right? It all starts with the capability of doing all these different types of tips, right? So you want something that could do a simplex fiber, can do a duplex fiber, as well as these multi-fiber, right? If you haven't worked with an MPO style inspection probe before, it's kind of cool. There's actually a motor that's built inside that'll it'll actually automatically pan across and scan all all 12, all 16 your fibers, even all 24. And basically automatically test and give you a pass-fail result for all the connectors on that interface, right? But again, you don't just want the MPO capability; you're also going to want the simplex capability as well. So everything kind of starts with the tip, right? And then you get to more of the workflow, right? And saving the results, preloading file names. We'll even talk about what we call test process automation, which is even loading actual like job walkthroughs. So not just the file names, but you would be able to preload all the settings and all the requirements and all the test parameters on the instrument as well, if you want to fully kind of take control of the testing. So it's not just the scope anymore, right? Now we're dealing with things bigger than the scope, right? With these test flows and automation, just to make sure that technician that's on site is doing exactly what he needs to, no more, no less, has success, and then you're able to get out of there and move on to the next job, right? So that brings us to VIAVIs, right? Too many things going on here. There we go. That goes to VIAVIs, basically our brand new scope, what we call the INX 760. that it's basically our second generation. You may be familiar with the predecessor that was called the Sidewinder, right? That was out there, did its job, but had some tweaks that we wanted to make, as well as the Sidewinder really wasn't designed to handle all these test flows and connecting to the cloud and those kind of things. So the INX 760, right, not only has the capability to now to connect and pull all these the file names and pull these jobs, but we've also tweaked several aspects of the hardware just to make the testing go that much easier, right? And the big ones, right, our inspection tips now actually have an intelligent chip built in, which is going to have all the settings that are needed. Right. So before, if you switched from MPO to LC, the inspection probe can do that, but there were certain settings that needed to be done. Right. In this case, now if you go from an LC to an MPO to an MMC, the settings for that particular tip are going to be automatically implemented, and it's done via an actual chip on the instrument as well. So no RF. That's part of this. No connections. It's really just as soon as you plug in and screw on that tip, it's gonna auto set the scope. So very easy to go back and forth between single fiber MPO. We even have a duplex tip that's able to measure basically 2 LC connectors at one time to try to help speed along the process if you're doing duplex LC. Typical things that you'll see, even with our predecessor scope, is the autofocus, right? It's kind of ergonomically designed to where you just plug in the fiber, pull the trigger, and then you could decide whether you want to have it autosave, or do you actually want to manually save it. Depending on the job, I typically recommend manually saving it, unless they want to see your failing tests as well. If you run inspection and it fails, some people want to see that, want to see the failures as well as the passing. Some are just send us the passing results. So in that case, you would, if you fail, don't save it, use your cleaning tools, get it back working. And then once it passes, that's the actual one the one to save. Field replaceable battery, as well as there's a, it's USB charging. So again, you could be out there with a USB charger, easily be able to handle that full day of testing. So most important things, like I keep saying, ability to do all the different types of styles of connectors, as well as being able to load file names, load job requirements, so that the technician, it's very hard, if not impossible, for them to screw it up and do a fat finger a name, do a test with an incorrect pass fail, those kind of things. So for VIAVI, the INX 760 is where you'll want to be for your inspection testing. And then when it comes to the tier 1 test, or basically the glorified light source power meter, we have what's called our MPO-LX, right? Again, really the major difference with this is, rather than have a single fiber port on the test equipment, it'll have native MPO, or basic 12 fiber connectors on the instrument, so that you could either plug directly into MPO cables, or you could use specialized jumpers and specialized cables to test your MPO8s or your MMC 16s and MMC 24s, right? It all starts with the native MPO 12 connector. And just go a little bit more in depth on what is a tier 1 test, right? Because again, it's in the service provider world, you don't really hear tier 1, tier 2. Tier 1 usually means the size of your company, not the style of the test. But anytime you hear tier 1 certification, that's going to mean loss, length, and polarity, right? So light source on one side, power meter on the other, right? The loss measurement, again, very straightforward. Again, that'll just be your typical insertion loss. The length of the cable, right? So again, it's not an OTDR by any means, but it is able to run a measurement that gives you the length of the cable, right? And then as well as the polarity. So I didn't really go deeply into it, but there are 3 different types of polarities with these cables. And by having two test sets that are natively MPO, part of that test is ensuring, is this the one that's polarity A, B, or C? So again, a pretty straightforward test. In our case, the testing equipment will actually talk to each other or interface. So as soon as you plug in on both sides, it'll beep. Say I see you, and then you run the test, and then all the results would, in our case, would be saved on the power meter that you could pull off at the end of the day. So kind of like I said, it's not the craziest, most complex test. It just gets complex with the amount of them that you need to do, as well as the different styles of connectors. And again, you're starting with an MPO 12 on the instrument. So when you need to do things like MMC 16, MMC 24, there's ways to do that. You just need to have your specialized cables and reference cables so that you can make that measurement. And we don't have time to go into those those different styles of references on today, but again, if we end up having a follow-up presentation or maybe we speak to you one-on-one, we could go a little bit more in detail on how those different cables look in order to test the different styles of connectors. Real important, just in case, a lot of times we run into people that want to reuse their old style of light source and power meter, which in that case would be, typically your OLTS, that would be, again, a light source and a power meter, but only a single fiber interface or a single fiber port, right? And then they would use these breakout cables to take the MPO to parse them all out into 12 individual files, and then you would test each fiber individually using those same test equipment. So, right, the general thought would be like, ooh, I don't need to invest in more test equipment. We'll just use what we already have. But again, if you look at the job from a whole and the amount of extra time that you're gonna need to test by doing that process, right, one fiber at a time rather than 12 at a time, the time saving is, it's not even close, right? We give numbers on the slide, but you don't even really need to spend time going into that. Just understand you're testing either one fiber at a time or you're testing 12 fibers at a time or 16, whatever it may be. So again, for anybody out there that's like, ooh, we do have our light source and a power meter. It's capable of performing the tier 1 test, right? You get your length, you get your polarity. Or in this case, you really can't do the polarity because it's single fiber each. So it's really just the length and the loss. Again, if polarity is required, you need to go to the MPO native test equipment. But even if it's not, the time savings that you're going to have just by going 12 fibers at a time rather than one, it's a no-brainer. And like, even if you have, let's say you have massive amounts of single fibers, simplex. So let's say they want you to do a couple thousand LCs, right? You could still use the MPO native cable. And in this case, rather than have cords that go MPO to MPO, you would go MPO into the test equipment and then the breakout cable into the individual LCs or whatever it may be when you plug into the fiber that you're testing. So again, you're testing single fibers, but you're able to do 12 of those single fibers at a time because you're using the MPO native interface. So tons and tons of time saving. I'll let you guys take a look at these numbers after. I'm not gonna waste your time just going, because it's pretty straightforward, right? 12 times, at least 12 times faster, if not better. The last kind of thing that I want to highlight with the MPLX tier 1 test set that VIAVI offers is, again, kind of loading those file names, right? And if you look on the left-hand side of the screen, that's the default mode, the manual tests that you're going to go through and have to test and then individually name each test that you run. Or what we call projects is where you actually have, you'll create a specific project with a specific label list. And then when you load that, all these, you could kind of see this one right here, all those file names are going to be preloaded. The guy in the field just needs to select which fiber they're on, run the test, and then just push the save button, and then the file name will be automatically preloaded. So when it comes to the tier 1 test set, again, now the focus is having the MPO native style capable of doing tier 1, as well as the ability to preload these file names as well as pull those results off and send them up at the end of the day. So again, yeah, just kind of highlighting the things that you want to look for. We do offer also simplex test sets as well. So if you just have the need for simplex fiber, we have the OLTS 85. But then again, the MPOX is probably what you're going to be looking at and working with for if you're doing any kind of testing inside the data center. Where once you get to the campus and the Metro DCI, maybe the OLTS or even our OTDRs will probably become more relevant. But inside, MPLX is where it's at. And how ours works is there's the power meter, right? There'll be just the one power meter that could accept multi-mode, single mode, whatever you want to plug in. But then for the source, because the source is fiber specific, you'll have either a single mode source or the multi-mode source. So a full kit would be 3 instruments, single mode source, multi-mode source, and then a power meter that accepts both, as well as your INX 760 inspection probe, right? And that would be all the hardware that's needed. And then real quickly, I want to just touch on an additional feature that can make your life that much easier, what we call test process automation, right? That's basically now, rather than just loading file names on instrument, it's basically pre-creating full jobs with the amount of fibers you need to do, the types of connectors, the pass-fail thresholds, creating these jobs at first, right? And then I think this slide does a little bit better of showing the flow, right? So somebody would create these, let's say you're in Amazon or Microsoft, right? Be like, okay, I need this contractor to do this specific testing, right? So we're going to create that test plan, right? And then they're going to send that into the cloud. And then the technician that's on site will then connect with that cloud, pull all those jobs down into the instrument, right? And again, it's not just file names, it's settings, it's pass-fail thresholds, whatever they're requiring. Do you need to take pictures on site? Do you need to do anything else while you're there as like a site survey or something like that? So the whole job workflow would then be loaded on the instrument, right? As you're testing, right? So if you're, a lot of times you can't have active connectivity inside the data center, right? They don't let you bring your phone or your laptop in or anything like that. But as soon as you get out of that environment, if you were then to connect to the cloud, you'd be able to send those results up daily or at lunch or whatever it may be. And then that job will be monitored by anybody that has access to StrataSync, our cloud solution. So they could be like, okay, this job is 15% of the way done. This job's 27% of the way done, and start to get a feel. It's like, okay, why is this going so much faster? Why is this job going much slower? Right? You have up-to-date analysis of how that job's going, right, all the way up until the end. Right, and then basically at the end, you'll have the kind of close the loop where you would have all the test results, and more importantly, all the processing of the test results done within the cloud. Right, that technician doesn't have to do anything but test and connect to the cloud. Everything else is done. So no post processing, no downloading results, none of that. Everything is just going to be automatically sent up through from the test equipment to the cloud to whoever wants to look at them. And then it's up to them. Are they processing it? Or are they just looking at it? Whatever it may be. So yeah, I think that's the general gist of it, right? Just kind of go in conclusion, right? You're looking at inside the data center, mass amounts of connections, many different style of connections, very basic testing, right? Inspection and tier 1, but just made much more challenging by the the things we just kind of referenced, right? And just a big emerging market, that these data centers are popping up everywhere, and it's essential that they work well, right? I think one thing I didn't mention before is, especially when you get to things like AI, right? If you have a bunch of servers that are supporting 400 gigabits per second, but one of them has a dirty connector, right, and is only running at 350 gigabits or whatever it is, telecom use cases, you could get by with that. But the way AI works is it's all that equipment's going to default to the slowest one, right? And then it may not be able to run, right? You may not be able to have your automated driving or your automated manufacturing. So the reason why these test requirements are so stringent in this market is they want to maximize the performance of these data centers. So yeah.
Awesome.
Any questions here? Anything else before we drop, Alan?
Well, first of all, thank you so much. I appreciate it, Jeremy. You know, the development and the construction of data centers are only going to rise. So I'm sure that there's going to be quite a bit of testing required for all these facilities to communicate properly. So thank you so much for your presentation today. I don't see any questions. I'll just give it a few more seconds. But again, before I do that, just again, this recording, this webinar is recorded, so we will send out to everybody, and not just for the attendees today, but also to the registrants. And it looks like there are no questions, Jeremy. So again, I want to thank everybody here for attending the webinar today. I want to thank VIAVI. I want to thank Jeremy. Great presentation. So much appreciated.
Yeah, thank you. I appreciate it. And any questions, just reach out to Electro, reach out to VIAVI. We'll be happy to help. Thanks, everyone.
Wonderful. All right. Thank you, everybody. Have a great day.